Hello everyone, welcome to Pepcoding. In this video, we will look at this question partition array into disjoint intervals. Okay, so let's take the problem statement from here, right? Okay, and also let's take the input as well. Let's take the sample input and the sample output. Okay, so it is saying that given an array integer nums, partition it into two contiguous subarrays left and right so that every element in the left is less than or equal to every element in the right. Left and right are non-empty. Left has smallest possible size. Return the length of left after such a partitioning. So let's say I have this array. Let's take this array 5, 0, 3, 8 and 6. Right. So I have to partition this array in such a way that all the elements on the left hand side will be less than or equal to all the elements on the right hand side. Right. So if I partition this array from here, right, if I partition it like this, then all the elements on the left are 5, 0 and 3, right, and these elements are less than or equal to 8 and 6, right. So I have to partition this array in such a way that all the elements on the left hand side of that partition will be smaller than or equal to all the elements on the right hand side, right. Let's take another example. Let's take this sample input 1, 1, 1, 0, 6 and 12, right. Now I cannot take like random numbers. I cannot make a subset. I'm not making subsets, I'm making a contiguous sub array, right. So I have to, it needs to be contiguous, right. It needs to be like this only. So if I partition this array from here, from this point, then all the elements on the left hand side, all the elements on the left hand side 1, 1, 1, 0, all these elements are less than equal to all the elements on the right hand side. Okay, this should be the case, and this is how we are going to solve the problems. Okay, so in this question, what we have understood so far, let's say we had these elements a1, a2, a3, a4, a5, a6, a7 and a8, right. If I partition this array from here, right, if I partition this array from here, I can only partition this array from here or vector from here if all the elements on the left hand side, let's call them capital A, and all the elements on the right hand side, let's call them capital B, right. I can only partition this vector from this position only if this A or the elements in A are less than equal to or the elements in B. Okay, I can only partition it like this if all the elements on the left hand side are less than equal to all the elements on the right hand side. Okay, so this is my question. So I hope you understand the question. Now let's try to discuss the approach. Okay, and before actually discussing the approach, we are going to discuss the impact of a number, right? What the impact of a number actually is. So let's say that I've sorted this array, right? Let's say I sort this array. Right, if I sort this array, I will get 3, 6, 9, 10, 11, 12, 13 and 15, right. This is what I'll get if I sort this array. Now let's see, let's look at 10, right. Let's look at 10. Now 10 wants to be here, 10 wants to go to this index, right. 10 wants to go to 3, third index. 6 wants to stay here only, 9 wants to stay here only, this 3 wants to go back to 0, right. This 3 wants to go back to 0. Now let's take a different color. This 12 wants to go to here, right. This 12 wants to go to 5th index. This 15 wants to go here. This 11 wants to go here, and this 13 wants to go here. Okay, so these are the positions that they want to be. If they were to be sorted, these are the positions they would like to go. Okay, so we can see that 10 wants to go here. So the impact of 10 is in this range only. right? 6 wants to stay here only, 9 wants to stay here only. The impact of 3 is in this range only, right? Now 12 wants to go here, right? 15 wants to go here, 11 wants to go here, 13 wants to go here. So the impact of all these numbers, right? Impact of all these numbers are at this range only. So it means that if I partition this, if I partition this array, if I partition this array or this vector like this, right? If I partition it from this point, if I partition it from this point, then I can see that the all of the impacts on the left hand side are still on the left hand side only, and all the impacts on the right hand side are on the right hand side only, right? I'm not changing the impacts of the of them, right? I'm just saying that all the elements on the left hand side wants to stay on the left hand side, and all the elements on the right hand side wants to stay on the right hand side. And all these elements on the left hand side, when sorted, are less than or equal to all the elements on the right hand side, right? They are already less than equal to. So I can say that I can sort this array, or I can sort this vector at this position. Okay, this is going to be my partitioning. So this is the right partitioning, and I'm judging this on the basis of the impact of every number, right? So how are we going to calculate the impact, and how are we going to uh, let's see. Okay, let's see what we'll do. Actually, we will have, okay, so okay, so we will have an array called right min, right? We will make a right min array. We will make a right min array. This will calculate the minimum value on the right hand side, right? And we will maintain a left max variable. This is a variable. This is not an array actually. This is just a variable. But I'm trying to maintain the variable, so I'll already write the values like this only. Okay, but this actually is a variable. So this left max, or and in this right min, first I will try to calculate the minimum value on the right hand side. Okay, so if I were to fill this, the minimum value on the right hand side from here will be infinity, right? From here the minimum value is 13, from here the minimum value is 11, from here the minimum value is 15 or 11 only, from here the minimum value is 11, from here the minimum value is 3, from here the minimum value is 3, from here the minimum value is 3, right? From here the minimum value is 3. So this is my right min array, right? Now let's find the left max, right? What is going to be my left max? The left maximum till here is 10. The left maximum till here is 10. The left maximum till here is also 10. Till here is 10. Till here it's 12. Till here it's 15. Till here it's also 15. Till here it's also 15. Okay, so it means that this is going to be my left max. This is actually a variable, this which will change its values, and on the basis of that left max I will check in my right minimum, and I will see the impact of every number, right? So let's see what we are actually doing. Okay, this may be a little confusing, but as we go along you will understand it. Okay, so the left max here, we will compare the left max here with the right min here. Okay, now this 10, this left max is greater than the minimum element on the right hand side here, which is 3. So it means that this 10 can exhaust this 3, right? This 10 can include this 3. So I will increment my left max. Okay, what I'm saying is that this left max is greater than my right minimum. So it means that I can exhaust this 3, right? So if I can exhaust this 3, then I can include it in my range. So I'll increment my I here. Okay, now I'll compare these two again. Now 10 and 3, then I can exhaust this 3, so I'll increment again. Here, same thing. I can increment again. But now at this position, okay, this is the main position. At this position, have my left max as 10 and my right min as 11, right? At this position, my left max, my left max is less than equal to my right min, right? Right min of I plus 1. At this position, the left max is less than equals to the uh, right min of I plus 1. So what does this mean? Okay, let's say I have this array, right? And I have this partitioning. And it is saying that the left max here is 10. The right min here is 11. So it is saying that the minimum value, or the minimum value in this array, in this part of the array from here is 11, right? From here, the minimum value is 11. And in this array, the maximum value is 10. So it is saying that the maximum value till here is 10, which is smaller than the minimum value till here, right? Which means let's use the approach of binary search tree. Okay, in a binary search tree, let's say I have a 5 here, a 2 here, a 3 here, then a 7 here, and a 6 here, right? In a binary search tree, there is a property that every node on the left hand side will have a smaller value, and every node on the right hand side will have a greater value than me. Okay, so for 5, I have 2 here, which is smaller than 5, right? All the elements on the left side of this subtree will be smaller than 5, and all the elements on the right hand side of this subtree will be greater than 5, right? So if you see the maximum of this left, right, this maximum subtree, the maximum of this left is 3, right? This is the left maximum. And on the minimum of this right hand side, this right subtree, the minimum of this right subtree is 6. Now you can say that 3, or the maximum value on the left hand side, is smaller than the minimum value on the right hand side, right? This means that the maximum value on the left hand side is smaller than the minimum value on the right hand side, which means that even the even the smallest value even the smallest value on the right hand side even the smallest value on the right hand side is greater than the largest value on the left hand side, right? It means that even the smallest value on the right hand side is greater than the largest value on the left hand side, right? So at that moment, I can for surely say that I can partition my array from here, because at this moment, even the minimum element on the right is greater than the maximum element on the left. Okay, so I can partition it completely well from here. This is my logic. What we have done so far is we've created our rmin, which is right min vector, and my second step, I've maintained a left max. Okay, this left max will tell me what is the maximum value on the left hand side, and I've maintained and I've made a right min vector which will calculate the minimum values on the right hand side. Okay, and the third thing is the main condition, which is if left max becomes less than equals to my rmin of I plus 1, at that moment, if there comes a moment when my left max is less than equal to I plus 1, then at that moment I can say that that index only is my correct partitioning. So I'll add that to my answer, or I'll save that index. I'll break my loop from here. Okay, so this is my question. Now let's try to code this. Okay, this will be more clear as we code. Okay, so the first thing is store the size. So array dot size. Okay, now we will make a vector int rmin of size n plus 1, right? And at the end, I don't have anything which is smaller than the last value, right, on the right hand side. So int max here. Now we will run our loop from the right hand side. So int I is equals to n minus 1. I is greater than equal to 0 minus minus I, right? Now I'm checking from the right hand side. So rmin of I is equals to the minimum value between rmin of I plus 1, right? And ARR of I, right? This will give me the minimum value. This will fill my vector with the minimum value, right, on the right hand side. So after this, after I've filled my right min, I just need a left max. Let's initialize it with integer min and answer, which will store my index, right? Now I'll run a for loop from 0 till n, right? And I will check, or first I have to maintain my left max, right? So my left max will be the maximum value of my left max and array of I. So this will tell me the maximum value till that point, right, on the left hand side till that point. So now I just need to check if my left max is equals to less than equals to the value at right min I plus 1. Okay, if this is true, then I know that at that moment, even the smallest value on the right hand side is greater than the maximum value on the left hand side, right? So I'll store that index and I will break from here because I've found my first partition. And since I have to return the higher index, I'll return answer plus 1. Okay, so this looks fine. Let's run this code. It is successful. Let's submit this. It's also submitted. So I hope you understand this question. If you don't, I would suggest you watch the part which you don't understand. Don't forget to like, share, and subscribe. Thank you for watching.